Yes, welcome. By names of Senkungueno Martin. This is our week 5 assignment, and today we are going to be exploiting the MLOps for audio source separation. MLOps is a short form for machine learning operations, which refers to a set of practices, tools, and methodologies used to streamline, automate deployment, monitoring, and management of machine learning models in production environments. Now, for audio source separation, which is a project I'm working on, the MLO practices can help to streamline the deployment pipeline for training audio separation models, ensuring consistency and scalability and reproducibility. Now, the influence of MLOps trends and techniques. For the trends, it's trending mostly in automated mode of deployment and monitoring. For the techniques, model versioning, the CI/CD. Then for the impact of audio source separation, its impact on audio source separation, by automating the deployment processes, the project can deploy trained models more quickly and consistently, allowing for faster iteration and experimentation. Then for model versioning and CI/CD pipeline, can ensure that the changes in audio separation are tracked, tested, and deployed efficiently, leading to more reliability and scalability. Then the application of the DevOps and the DataOps. For the DevOps, when applied to machine learning workflows, the DevOps principles, they emphasize the need for collaboration between data scientists and developers. Then the automation plays a crucial role in DevOps for machine learning, which enables automated building, testing, and deployment for machine learning models. Then for the DataOps integration involves implementing automated data pipelines for data ingestion, cleaning, and processing. In DataOps also, there is data versioning and lineage tracking, which are essential aspects in ensuring that data is maintained throughout the workflow. Now this image here, this image explains more about the DevOps and the DataOps. For the DevOps process, there are 5 stages. There's development, building, and testing, which is the CI. Then there's deployment, then running. For the DataOps processes, there's sandbox management, development, orchestrate, testing, deployment, orchestrate again, then monitoring. Then the differentiation between heavy and light MLOps. For heavy MLOps, it involves extensive automation, monitoring, and governance processes. Then for lighter MLOps, it only focuses on minimal overheads, simplicity, prioritizing the agile and experimentation. In simple terms, heavy MLOps, it's a bit more expensive, and it involves more investment in infrastructure, tooling, but later it leads to a greater scalability and reliability in the long run. And yet, for the light MLOps, they are more suitable for smaller scale projects with limited resources, allowing for faster iteration and experimentation. Here's our image which explains a bit more, which shows the differences between the heavy and light MLOps. And this image here shows the MLOps hierarchy of need stages. At the bottom we have the DevOps, and then the DataOps, the platform automation, and then the MLOps. And MLOps have problem framing, there's business ROI forecasting, predictions, and pattern discovery. This slide here shows the project progression through maturity levels. It's a model in production against MLOP maturity. So initially at the first stages, they establish the experimentation environment and then standardize the code repositories and ML solution deployment. In order to make it reliable, they introduce testing and monitoring and multi-account deployment. And then to make it scalable at last, they temporalize and productionize multiple ML solutions. The strategies for data management and microservice operationalism. Data poisoning, its implementation is by implementing the robust data validation and anomaly detection techniques to identify and mitigate data poisoning attacks. Some of these techniques are data lineage tracking, model explainability to ensure data integrity. Then for the problem of data drift, there is employing of continuous monitoring and feedback mechanism to detect data drift, where statistical properties of the input data changes over time, implementing the retaining strategies and the model reevaluation to adopt the valuing data distributions and maintain model performance. Then operationalizing microservices. There's designing and implement of microservices to enable scalability, flexibility, and agile in model deployment and management. And the role of here's the importance of the role played by the continuous integration, that's the CI, in continuous delivery, feature storage, and then Python file. Then for continuous integration, the CI, and continuous delivery, the CD, implementing the pipeline to automate model training, testing, deployment processes, ensuring code consistency, reliability, and scalability through the automated testing and version control. So we also have feature stores, utilizing the feature stores to manage and share feature engineering pipelines and datasets across the ML flow, the workflow, enabling efficient feature reuse, versioning, and tracking to streamline model deployment and development. Finally, the importance of Python project files is emphasizing the significance of well-structured Python files for productability and collaboration, organizing code, data, and documentation in modular and version controlled manner to facilitate code reuse, debugging, and replication of the experimental results. Thank you very much for watching.